Thanks a lot for the invitation and introduction. So I wanted to speak about the intersection cohomology of Shimura varieties via the approach of newly constructed geometric object on the Igusa stack. And all I'm speaking today is a joint work with Caraiani and Linus Hamann. And this is still very much in progress. So in case I made any mistake, it's really my fault. So what I want to start with is the extended motivation on why people are interested in intersection cohomology of Shimura varieties. So let me therefore start with the L2 cohomology of locally symmetric spaces, which is the object people studied before intersection cohomology and intersection. So let me immediately put myself in the situation where we have the Shimura variety. So let's fix a Shimura datum consisting of the reductive group G over Q and the symmetric space for its real point. So therefore it can be written as the real points of the group modulo stabilizer at a point. So this is a confusing notation because my case of infinity is not necessarily but the issue is only after the connected component of the maximal arc torus in the center. So this datum gives me a tower of algebraic varieties labeled by compact open sectors of the finite adelic points of G. And they're defined over a number of fields, partially flat fields, and these are called Shimura varieties. So if we took the complex point of the Shimura variety labeled by K, then this has a presentation as a adelic double coset by taking the product of this metric space with this finite adelic group and left quotienting out the diagonal action of the rational point of G and right quotienting out its levels of group K. So let me also, for simplicity, write X sub K for this double coset as a complex surrounding. And then the space is equipped with some G invariant Riemannian matrix, with respect to which one can take the L2 cohomology was complex coefficient, and which by definition is the hybrid cohomology of complex of smooth differential forms that are square integrable with respect to this. And the reason why this cohomology is interesting is that it can be immediately related to automorphic representations in the following sense. So first of all, by investigating the relation between the tangent bundle of the symmetric space with V algebra, this can be identified, shown by Borel, with the relative V algebra cohomology with coefficient in the L2 smooth vectors and the L2 functions of some space, x k tilde, where this x tilde is again an adelic double coset, which is obtained by this from this by modifying the top and replacing the symmetric space by the real points of G, so that you get the full adelic group here. And left quotienting out twice rational point, and right quotienting out K. And again, to make it a finite volume, let me also quotient out the connected component of the maximal R squared torus in the center. But in practice, we will not care about this, and this is just copies of the positive part of the numbers. But the upshot here is that now this L2, the space of L2 functions on this coset decompose. So invoking the spectral decomposition of the L2 functions, in particular, actually the free part that decompose further into direct summons labeled by discrete automorphic representations. And which by definition are those irreducible representations appearing in the discrete spectrum of the scope. And then each appearing with some multiplicity 5, and each of these representations also decomposes into the final part. Then what remains in this formula is the relative Lie algebra homology coefficient and the smooth vectors in the root part answered with K invariant in the finite part. So and what is nice about this formula is that on the L2 cohomology, there are some rich structures, in particular a C-star action coming from the Hodge decomposition, and then an SL2 of C action coming from the lifting, the SL2 triple coming from the Lepschitz operator and its system. And there is also a Hecke action. So this is also a module under the Hecke algebra labeled by K with complex coefficient coming from this analytic double possible presentation. So, and this spectral decomposition of the cohomology separates these actions. So the C-star and SL2C part comes purely from this relatively algebra cohomology, and the Hecke module appears here. And as Ada has commented, in this situation, so this decomposition separates conveniently this further study of this cohomology into three distinct objects: this real part, this finite part, and this multiplicity. And so just as a side remark, he also commented that the multiplicity is the deepest of all three, because the multiplicity being non-zero indicates a subtle relation between this real representation and this Hecke module, which a priori doesn't have to do with each other. And this is also part of the motivation. He invented these so-called alpha parameters to try to capture those automorphic, so those real representations that can appear as part of an automorphic representation, but that will carry us too far. So, but so far in this picture, no arithmetic information is involved. By which I mean any Gala action on the cohomology groups. But let's observe that if our locally symmetric space or the Shimura variety is compact, then the L2 cohomology by definition agrees with Zhang cohomology, because all smooths are automatically square integrable, and this compares with the singular cohomology, the C coefficient, and further compares with the tau cohomology of the algebraic companion. Where I have secretly chosen an isomorphism between C and QR. And now on the right hand side, there is an action of the absolute Gala group of the reflex field. But when the so in this way, you see all the structure in one cohomology group, which is good. But when the space is not compact, still through the relation to Zhang cohomology, one has a map. One has a map from the L2 cohomology to singular cohomology. Generally, this is neither surjective nor injective, even though the latter does compare with the cohomology and carries the LO action. So this is where, but on the other hand, the singular cohomology group is not that easily related to automorphic representation, even though one can do this, and this is a result of Franca, but the result is much more complicated. So this is where the intersection cohomology comes in. Namely, it was conjectured originally by Shimura and proven by Lianga and Stern separately that, in fact, the autocohomology compares with the intersection cohomology of the available route or minimal compactification of this symmetric space, both-way symmetric space. This is either called the minimal compactification or fairly route compactification. And which compares with its homology analog for this algebraic companion. Which now has carries the dollar. So and then because recently in our joint work with Patrick Daniels, from Hoften, who gave a talk earlier this week, and Daniel Kim, we have constructed certain geometric objects like Igusa steps to study usual cohomology and complex support cohomology of Shimura varieties, which turned out to be quite fruitful. And therefore, our motivating question here is whether we can apply the same strategy and put out ourselves in this formalism to study also the intersection cohomology. So, I mean, therefore, discuss very briefly this setup of the Igusa steps and how they were used to study the cohomology of Shimura varieties. For this, so rational time t and applies above off the reflex above t, and consider this local field obtained by completing the global reflex field at the place, and then base change our Shimura variety to this local field. And I'll also consider a variant of this finite level Shimura variety by taking by fixing an away from T level and take the inverse limit of the Shimura varieties at all finite levels in T. So now on this infinite level Shimura variety, Scholze has defined so-called touch-shaped map. So with target being some flat variety attached to the base change of our global G to QP and parameterizing iterations of type mu inverse, where mu is the Hodge covariance determined by the Shimura data. So, except that to make sense of this map, one has to take analytification of the Shimura variety. Here I use the symbol diamond to indicate that I'm viewing everything as a sheaf on perfectoid spaces equipped with the suitable topology. And this map is denoted by pi of shape. So, as in the classical case of smooth projected curve, this flat variety can be interpreted as a modelized space of minuscule modifications of trivial G-tossers on the so-called compactified curve. So, in this way, by projecting to the modified bundle, I have a map from this flat variety to 1G, the stack of G-tossers on the curve. And this map is defined using the Bouvier-Lasso uniformization on the curve. So that we call it Bouvier-Lasso map. So then the main result from the joint paper of Ms. Patrick Daniels, Hoften and Daniel is that we have shown in the case of Hodge type Shimura varieties, there's a way to complete this diagram to a Cartesian diagram. Well, precisely, there is a functorial construction. So functorial in Shimura datum, or Hodge type Shimura datum. Okay. We call Igusa stack. So this is a stack tested on perfectoid spaces equipped with the so-called V topology. And we denote it by IGSK upper P, and which sits inside a Cartesian diagram listed the other three objects in the other three corners. And the Igusa set maps to Gongji with image lying inside the locus corresponding to the couplet set BG inverse. This is an open locus in Gongji. And so, and then in this paper, the same paper, we have applied this result to deduce many interesting results on the cohomology of Shimura varieties. And in particular, we get Mandelbrot's product formula, isolate Shimura relations, and Ewing-Hardy levels, and some vanishing type of results for the generic part of the cohomology. But instead of going into the statement of these results, let me just present the basic idea of how this diagram can be applied to study the cohomology of Shimura varieties. So, which is the three steps of all these other cohomological consequences. So for this, let's consider arrow-added cohomology, where the coefficient range lambda is some portion of the Noetherian zero alpha. Then the main observation here is that if we want to compute the cohomology of the Shimura variety, which by definition is the push forward of the constant local system from the Shimura variety all the way to a point which necessarily factors through this Hodge-type pure map to the flat variety. And let's call this projection Q. And and this, by the way, compares with the cohomology of the algebraic as algebraic companion. So I'll write directly just in here. Now, since we know the local system on the Shimura variety is also pulled back from the Igusa stack, and this, so we can rewrite this push forward as the first pullback and then push forward and then push forward. But the first pullback and push forward using a base change of along this diagram can also be written as the push forward first from the Igusa stack to G and then pull back using the push forward. Benefit now here is that I have constructed some complex on G, which governs the cohomology of the Shimura variety in the sense that once I apply this operator, pull back and push forward, it recovers the cohomology of the Shimura variety. But what is more interesting, well, first of all, because I didn't state this, but this diagram is in fact equivariant under the Hefte action. And in particular, in order to remember the cohomology of the Shimura variety as a GQP representation, I can do everything on the top relatively over the classifying stack for GQP. And now, when rewritten this way, then this operation of pullback and push forward identifies with a restriction of the Hecke operator defined in the Scholze's geometrization of the local Longland setup, labeled by this minuscule co-character mu, and then applied to this sheet, which I did not apply or star up to a shift and twist, where in the shift and twist, B is the dimension of the Shimura variety. So the upshot here is that in order to study properties of the cohomology of Shimura varieties, we can separately study this Hecke operator and this complex on G, where in fact, since this Hecke operator is a purely local operation, one knows quite some results, and notably by the result of Linus Hamann was in the audience. And now the goal for our current project can be stated therefore more precisely, and that we want to do the same thing for the intersection cohomology, and namely we want to construct some complex G, so that once we do the same thing, applying the same Hecke operator to it, it recovers the intersection cohomology of the Shimura variety. So before stating our expected results and probably some strategies we had in mind, let me just quickly also talk about minimal compactifications so that we could even so that we could talk about intersection homology in this context. Are there any questions so far? So so for the Shimura varieties, the main result concerning minimal compactification is due to separate works of Satake, Billy Borrell, and Richard Pink. Which can be stated as follows. So for any small enough compact open subgroup of the finite adelic points of G, there is a normal objective algebraic variety defined over the reflex field of the Shimura variety, and dense open immersion from the Shimura variety is the same. And moreover, so Satake first did this on the level of topological spaces, and Borrell showed that it has an algebraic structure, and Pink showed that it actually has a canonical model. And moreover, this minimal compactification has that theoretically a stratification into strata labeled by conjugacy classes of admissible, the so-called admissible rational parabolics. And each of the stratum looks like the union of smaller dimensional Shimura varieties attached to a subgroup of the levy of these P's. When the level is different, this might be up to a finite function. Even though the combinatorics of compactifications is usually very annoying, but these compactifications are very important, and they're interesting because the geometry near these boundary components are closely related to this operation of parabolic induction in a representation theoretic sense. In particular, Pink has shown that if you compute nearby cycles close to these boundary components, then you will show parabolic. As representations, you will see parabolic induction here. So, and very rough idea of the construction of these minimal compactifications is that you take the symmetric space and then first add to it set theoretically its so-called rational boundary component. it's the same labeling. And then we put this with the so-called certificate topology. And then construct a compactification of this localized metric space by replacing this metric space in this adelic double concept presentation by this F star. And then you go on from there to show that it actually has an algebraic structure and a canonical model. A really quick example for us to get a sense of what this rational boundary component is in a case where our group G is GL2, and the symmetric space is really just a union of complex upper and lower half planes, and then the rational boundary components we have to add is just the rational points on the real line. So this is the construction for Shimura varieties, and then for Igusa varieties, for Igusa set.
You don't need to point it at intermediates. If you want.
Okay. For the Igusa stack, it was done in my thesis from last year, but under some maybe nowadays I feel a little bit annoying assumption, namely when the Shimura variety is PL type and type AC classified by complex, and there's also the condition that this this space change of G to QP is a ramified, and plus that the codimension of the boundary of minimum compactification in the Shimura variety is at least 2. Then in this case, I showed that we can compactify the Igusa set to get a minimally compactified set still living over upon G, and then uniformizes minimal compactification of the infinite level Shimura variety when you pull back to the flat variety. And the rough idea for constructing this compactification is to use the knowledge that on the minimal compactification, the hot state period map behaves like an affine map, and therefore I can take the relative affinization of the open Igusa stack over upon G, and when work a little harder to make sense of that, and then the codimension condition comes in when we try to say that there is, in this situation, an analog of the algebraic Hartogs principle, so that the relative optimization did give me the correct thing. So, in this context, okay, I can start good. state our expected result. So we're probably would have to put ourselves in the same situation as before, when we have minimum compactification of the ecosystem. And then that portion, I'll add it. And we factor that there exists an IC complex in the direct category London modules from this minimally compactified ecosystem was the property that, first of all, it recovers the IC complex, the intersection complex on planet level Shimura varieties, or in the following sense. So, for any pro-P subgroup, open compact subgroup of the Russian QP points of G, I can look at the minimally compactified Shimura variety at infinite level, quotienting out this level subgroup as a step quotient, which maps to the minimally compactified Igusa stack because the vertical map above is GQP equivariant, and this projects to its coarse moduli space, which is the Shimura variety at the finite level, and I call this map UKP, and the vertical map is HKP. Then we expect that the push forward along Q of the restriction of the intersection complex along HKP is just the usual intersection complex on this finite level minimally compactified Shimura variety and taking this analytification. And then we accept that this intersection complex should be universally locally acyclic with respect to the projection from this Igusa stack to the point, and it should also be severe self-dual. And then when these two are in place, we should construct the complex we want at lower IC on bound G by just taking the push forward of this IC complex from the Igusa stack to bound G. And for this push forward G, we expect this to be reversed with respect to a perverse T structure on G. Given by the stratification coming from the Hamann or Kim structure of G bond goes on the next.
Can you just ask a small question?
Yeah.
So what is the nature of this map QKP at the bottom? The source and targets now look very similar. Like
Right, the problem
typically
is
those-
only about stabilizers that, on the boundary. But when we restrict the pro P subgroups, we hope that it doesn't cause extra problem for our edit.
but away from the boundary, it's just a similar question, right?
Away from the boundary. So I write it this way just because one has some already defined IC sheets here. You could also make sense of a stratification on this object and say that when I pull back, I recover the IC complex on this steppy portion.
Yeah, no, I forgot that if you go all the way up in compactify and then act, it's not a free action. So somehow it's like a coarse modular map or something.
Right.
Thank you.
Are there other questions? Not, I want to make a couple of remarks of on.
So I do have a question.
Yeah.
The first three things you wrote down now, that implies that if you apply hack operator to FIC, it gives precisely cohomology.
Yes.
Question.
Yeah.
So what do you expect for compactification for Shimura varieties? Like, is it global in the near future, or it requires like
It is a
sorry, compactification of all the Shimura varieties? Does it require similar ideas as these, or something that
compactification of Shimura varieties.
like something which are not P or AC?
Yeah, or Igusa stack, maybe.
Sorry, Igusa stacks. Sorry, yes.
Yeah, right. This is yeah. So the key ingredients used in this fruit actually back then it was not available, but actually now they become available after the work of Shankai Mao, who was a student of Hamann, and we hope that we. At least I believe that the same strategy should work to prove the existence of the minimal compactification for Igusa stack of spectrum of varieties under the same condition on the codimension of the boundary. So let me make a few remarks. So first of all, I want to say that when I say Fadir duality in the second part of the expected result, there's implicitly some T structure on the direct category of long-term modules on the Igusa stack. And indeed, our strategy for constructing this IC complex is to define stratification on the Igusa stack by taking image of this stratification on the Shimura variety. Using also the fact that the map from the Shimura variety to the Igusa stack, once you pass to function on both sides by the QP points of G, this map is a cohomologically Scholze, so that when I take the image of this locally closed stratification, this should hopefully also give a locally closed stratification on the Igusa stack. And then using this, we should be able to define And also, sorry, on the stratum, there should be a reasonably defined dimension functions so that we can define a perverse T structure as usual on the derived category of these Igusa deck. And then we will just define these IC to be the intermediate extensions of the constant local system on the open on the open Igusa stack. And so far, using this definition, many things seem to work out, although it's very hard to work with these stratum because they are defined so explicitly. And the second remark I want to make is that for free, this perversity of this complex is actually expected by combining 2 and the semi-perversity result, which is basically so because as I said before, on the minimal compactification, the Hodge-State period map behaves like an affine map in the precise sense that these fibers will be identified with the generic fiber of a canonical lift of some perfect algebraic varieties that are indeed affine. And then, therefore, using Artin vanishing, we can actually show, at least on the stuffs, that this sheaf FIC is semi-perverse. And then, now, by 2, if we know that the intersection complex on the Igusa stack is Verdier self-dual, then the Verdier duality on Banqi will also send this complex FIC to itself, because this is by definition, and the fact that the Verdier duality switches lower star and lower shriek, which agree in this case, is just the push forward of Verdier dual of IC on the stack, which is it's FIC itself. Then we expect that this perversity result of this complex actually will have interesting representation theoretic implications, in particular in combination with the knowledge of perverse T exactness of the Heck operators, which is due to Linus.
For one, you need to shift the upper star by D and D over 2. Because the heuristic is that this map should be smooth, and so it's going to be perverse T exact up to a shift, and then this push forward will be cohomologically proper of relative dimensions.
Thanks. And then maybe another remark I can say verbally is that this condition, this property of being universally locally cyclic is a finiteness property, which implies that the IC complex is reflexive, and which eventually leads to the Verdier self-duality. And the last thing I want to say is that once these expected results are in place, then there are some simple applications by following the same strategy as in our joint work with Patrick and Daniel, that one should be able to deduce immediately Mantelson's product formula. Generic vanishing of the generic part. Apologies. So in this case, the statement would be on the cohomology, on the intersection cohomology of the Shimura variety. There is at the finite level, there is an action of the local Hecke algebra, and then if we localize this cohomology at a maximal ideal of this local Hecke algebra, which is generic in a suitable sense, then this localized cohomology is concentrated in the middle degree. And as well as Ashwa-Shimura relations. On the intersection cohomology of these Shimura varieties at Iwaharic levels. It's probably worth mentioning that. So usually when we state Ashwa-Shimura relations, when people state Ashwa-Shimura relations, this is for cohomologies at hyperspectral levels. But in our joint work with Paul, Patrick, and Daniel, we have proven these Ashwa-Shimura relations at deeper levels. Actually in between all levels, in between the Iwaharic and the hyperspectral.
This generic vanishing is for non-Eisenstein?
Sorry, this is for. So this is a slightly different setup. So the non-Eisenstein condition you mentioned is in the original Caraiani Scholze setup, where you look at the action of the global Hecke algebra, and then you look at some maximal ideal of the global Hecke algebra, such that it has an attached global Galois representation, which is absolutely irreducible, and then you can say that this is a non-Eisenstein maximal ideal. But in this setup, I'm saying it's more in the flavor of Linus and Celine, where their condition is that you look at. Sorry, let me write a little bit here, because I still have some. So if you look at this variety, this on the fixed level at P, then it has an action of the local or spherical Hecke algebra. Maybe let's say this is a hyperspecial. So subgroup, and this is a spherical Hecke algebra for KP, Lambda coefficient. And then here you can look at a maximal ideal of this local Hecke algebra, and then it has an attached unramified L parameter, and then you say that that parameter is generic in the sense of lines. And my statement of vanishing here is that if I look at this cohomology group and then I localize at this maximal ideal, if it's attached L parameter as generic, then I have concentration at the middle degree. And the statement here I want to make is that this is true not just for the usual or compactified cohomology, but also for intersection cohomology. And right, and then because I will not have time to explain the precise statement of these results, but what I also maybe find worthwhile to point out is that the Shimura relations at the Uraharic level in our joint work with Paul Patrick and Daniel was under the conditions that the Shimura variety is Hodge type and the group, this local group at P is ramified. But in a very recent preprint by Thibaut van der Kolbe, he managed to remove the condition that this local group is unramified. And hopefully, if we can construct minimal compactifications of Igusa stacks also in this generality, then one can get a much better and unconditional statement about these relations for all Hodge type Shimura varieties and also on the intersection. Yeah, that's roughly what I want to say, and I think I still have 2-3 minutes, so wait if you have a question.
Questions?
But like in this setting, if you localize at a non-Einstein ideal,
Mhm.
these like do we recover like normal at cohomology?
Sorry.
If you localize intersection cohomology at a non-Einstein ideal.
So the right so I think if we put ourselves in the situation where this global maximal ideal you're talking about has a attached to Galois representation, then the same thing should hold true.
Yeah, but there's gonna be no difference then.
Right.
Between the intersection.
Okay, that is a little.
Right.
I think
But,
that's quite interesting.
But the problem is that generally for like Shimura varieties other than unitary Shimura varieties, these maximal ideals of the Harkova but do not have the attached global Galois representation.
Can you also do QL coefficients?
That's a good question. I think this is more like technical
No doubt.
point, but no, yeah, but I do think we will try.
I mean, you still get new vanishing theorems that probably are unattainable by other means.
Yeah, I'm pretty sure. Shoes are all low.
Just take the limit.
In the proof of the expected result, do you use a codimension 2 assumption again?
So this codimension 2 assumption appears only for the existence of minimal compactification of Igusa stacks.
So if you assume the existence, the proof work in general?
Right.
If they exist in that diagram is sort of still Cartesian, is that enough formally? Okay, if there are no more questions, let's thank Mingjia again.